Back to my YouTube channel. Today we will study a topic of food science, enzymatic browning. So, what is enzymatic browning? Enzymatic browning is an oxidation reaction that takes place in some foods, mostly fruits and vegetables, and which causes the food to turn brown. So basically, enzymatic browning is that oxidation reaction taking place in fruits and vegetables that cause them to turn brown. Now some examples of enzymatic browning: fruits, apple, pear, peaches, apricots, bananas; vegetable, potato, brinjal, lettuce; cereal, wheat flour, rice; and seafood, shrimps, spiny lobsters, and crabs. Now let us see reaction mechanism of enzymatic browning. In intact tissue, phenolic substrates are separated from phenolase and browning does not occur. So in an intact tissue, phenolic substrates are present and phenolase are also present. So these remain separated until the tissue is worn out or cut, and due to which the browning does not take place. So when these cut surfaces, when we cut the fruit, so when these cut surfaces are exposed to air contains oxygen. So when oxygen reacts with these phenolic substrate phenolase, so it causes rapid browning of the food product due to enzymatic oxidation of phenols. So all the phenolic products like phenol substrate or phenolase, what are these phenols? So due to this oxidation carried out with the help of enzymes causes the phenols to turn to orthoquinones, which further changes or polymerizes to form brown pigment called melanin. So there are various enzymes that are catalyzing or helping oxidation of phenols, and these are basically known as phenolases. So some examples of phenolases, or you can say examples of the enzyme that causes oxidation or enzymatic browning of food are polyphenol oxidase, or we can say PPO, triosinases, and catecholases. So these are enzymes. Now let us study the steps of enzymatic browning. Step 1: hydroxylation of phenols. So once enzymes and molecules introduced have been released, monophenols and polyphenol oxidase will find each other. So once the enzyme and the molecules basically oxygen and the enzymes which are already present in the fruit, once these are released, so what happens? The monophenols and the polyphenol oxidase is the enzyme PPO. So PPO and monophenol is the already existing compound that is present in the food. So both of these, monophenol and PPO, will find each other. So this is how it looks. Monophenol, there is a benzene ring and one hydroxyl group, or you can say one OH group is attached, and to the other end any other group can be attached. So this is how a monophenol looks. So once the monophenol and the PPO have found each other, the enzyme catalyzes a reaction to transform monophenol to diphenol. This is called hydroxylation reaction. So what happens when monophenol and PPO finds each other? The monophenol gets converted into diphenol. Diphenol has two OH groups in them in the presence of PPO. Second step is oxidation of diphenol. So what happens? This diphenol further gets oxidized with the help of PPO and the two OH groups. The two OH group, these gets replaced by two double bonded oxygen molecules. Two double bonded oxygen molecules like this. So these OH gets replaced by double bonded, these double bonded oxygen, and this structure is called orthoquinones. And this resulting structure is known as quinones. Next, step 3 is formation of colors. Quinones are very reactive molecules, so they do not need any enzyme like PPO or anything to react further. After a series of reactions, the quinones will have form polyphenols. So after a series of reactions, because these are very reactive on their own, they will keep reacting and they will ultimately form polyphenols. So what are these polyphenols? These are large molecules and which have colors like red, brown, or even black. So these are the colors which we usually see in browning after enzymatic browning. Now you can explain the whole lengthy procedure in short. If you want to explain it to anybody, so you can explain it like that cut the fruits containing catechinins, triosins, monodihydroxyphenol, or chronogenic acid. So these are basically fruits which are containing these enzymes. In presence of oxygen, that is air, and PPO, it gets converted to DOPA, and this DOPA further gets, in the presence of oxygen or air and PPO, gets converted to orthoquinones. Orthoquinones are nothing. Quinones, and this ortho is denoting the position of the OH group, where this like orthopara meta, they used to be positions. So these are nothing but these are just telling the position of the OH group joined. So DOPA gets converted to orthoquinones. Further gets polymerized to melanins, and melanin is what? The brown pigment which we usually see. So this is the entire topic. I hope you have understood. If you are finding my videos, my content helpful, please do like, comment your doubts or anything, and subscribe the channel for getting all the notification regarding the new videos uploaded. Also, do tell me if you have any doubt, or should I make the videos bilingual using Hindi and English. Basically, I was earlier doing in both of them, but then the videos were getting very much lengthy, so I can explain in any language, Hindi or English. So subscribers, viewers, please tell me whether I should make it in English or in Hindi, in which language you are more comfortable. I will make the videos according to that. Thank you so much for viewing my channel, and that's it.